Hello, welcome back to Cracking the Cryptic, and we're looking at a New Year's puzzle today, of course, Year of the Snake by Adrian. So Adrian is celebrating that the Chinese New Year, when it begins, will be the Year of the Snake, and also that the year that is about to begin is 2025. I know there's only about 87% overlap between the 2 years, but we are about to enter 2025, and as you can see from the totals of the cages in this puzzle, that is what is being celebrated: 2025, 2025 and 2025, and a cage that actually has 2025 in it. So I'm looking forward to this. It's a fascinating idea. With some trepidation. I think one of the testers had some trouble with this, so we'll see how it goes, but yeah, no idea. But very happy New Year to you. Tomorrow, obviously, first of a new year, but also first of a new month, and therefore Patreon Reward Day, and it's Blobs' incredible Sudoku hunt, The Hobbit, the follow-up to his Lord of the Rings. It's going to be fantastic. We're going to be taken, well, you're going to take yourself on a quest, I guess, to find the one true ring. Well, you'll have to see how it pans out, but what an opportunity to delve into J.R.R. Tolkien's world and Blobs' Sudoku world as well. It's a fantastic group of puzzles, 19 of them. If you manage to get through them all, you're in with the chance of a prize. And we are very proud of that. So that is coming up any moment, well, at 4 p.m. on the 1st. Now, what else we got going on Patreon? There's loads of other stuff, long videos, connections, crosswords. There's also all of our apps which feature, well, they feature regular killer Sudoku and line Sudoku, but not maybe what this puzzle is, which we will figure out as we go along. Certainly there's no snake puzzle app yet, but there is a Fog of War puzzle, which is very popular and is our latest one out. Then, of course, there's Fan Sudoku Pad and our merchandise. Do check it all out on the links under the video. But the first link is to this puzzle, Year of the Snake by Adrian, whose dad is celebrating a special birthday that helped give the genesis to this puzzle in the year to come. Anyway, what are the rules? The rules are normal Sudoku rules apply. 1 to 9 in every row, every column, and every 3x3 box. Digits in ordinary, not golden, killer cages sum to the given total, and digits can't repeat in a cage, so that's 5 different digits adding to 25. Digits in golden cages multiply to the given total and can repeat in a cage. So 6 digits there that can include repeats that have a product, if you multiply them all together, of 2025. Digits on one of the main diagonals, so that's one of the 9-cell diagonals, sum to 20. Digits on the other main diagonal sum to 25. That's a very unusual rule, but again 2025 is being brought in. Now, to celebrate the Year of the Snake, which it is in the Chinese calendar, a snake is hiding in the puzzle. This snake can move horizontally, vertically and diagonally from digit to digit, but cannot cross itself or visit digits in any cages. The snake is 12 digits long and has both modular and entropic properties. Now, that means the modular property is that for every, let's imagine that the snake went through those 3 cells. For every 3 cells on the snake, those 3 cells must include a digit from 147, a digit from 258, and a digit from 369. They are the digits of the various modulo 3s. So if you imagine slicing your keypad vertically, it's 1 from each set. But we're also told that this snake has entropic properties. And that means, in Sudoku terms, 1 from the low digits 1, 2, 3, 1 from the middly digits 4, 5, 6, and 1 from the high digits 7, 8, 9. Again, imagine slicing your keypad like that. So that's what's going on in the puzzle. I don't know what stage the snake will come into it. I suspect late on. But give it a try on that first link under the video. I'm not just going to restart it. I'm going to get the pen tool enabled, because actually even before I start it, I'm going to draw in the diagonals, because one of them sums to 20 and one of them sums to 25, and I want to know, actually let's do it in a different colour, so that might help talk about it. I can talk about the blue one and the green one rather than the positive and the negative. Anyway, there we go, year of the snake. Oh, I was going to restart my clock. Oh, I'm going to do that. Let's get cracking, and now I'm going to redraw those lines in. Yeah, that was a great effort at the line, wasn't it? No? I've lost my reason now. There we go. That's the green one. That's the blue one. It'll have to go into my honestly, the first pass of the mouse was almost perfect to those. Right, now, I'm seeing a 25 cage. Now, the only factors of 25 that are Sudoku digits are 1, I'm counting 1 as a factor for these purposes because it is a Sudoku digit, and 5. And therefore, I think this cage is made up of 2 5s and 2 1s in a bizarre, deadly pattern that must be resolved by the blue line. Now, I'm also seeing the 20 cage, which has to have a 5 in it, and then 2 digits that have a product of 4, so that is 1 4 5. I mean, that's a reasonable start. However, I'm now going to have to factorize 2025. Well, obviously, I'm going to just aid memoir this. Obviously, 5 goes into it twice. 5 times 5 gives 25, and any number multiplied by 25 ends in 25, 50, 75 or 00. So, how many 25s are there in 2025? So in 1,000, and I learnt this for countdown, there are 45s. So in 2,000 there are 80, and then there's one more, so it's 81. Oh, that is annoying. No, it's not annoying. 81 is, you know this better than I do, it's 9 squared, or it's 3 to the power of 4, and that's relevant in terms of factors. So the factors of 2025, the prime factors are 4 3s and 2 5s. Right, enough aid memoir. Now the only Sudoku digits that are made up of 1, 3 and 5 are 1, 3, 5 and 9. And these all have to be different, not because of the cage rule, which allows them to repeat, but because of Sudoku rules, which say that box 4 has to have 9 different digits in it amongst all the boxes. So that is 1, 3, 5 and 9. And now we have used 3 of the factors that are 3. Remember, there were 4 3 factors and 2 5 factors. We've used 1 of the 5 factors and 3 of the 3 factors. We've got to put a 5 in the cage and a 3. And I believe that it's Adrian's dad who's turning 81. And, well, I mean, 81 is the ultimate Sudoku number for a 9 by 9 Sudoku, of course. And 2025 is the only year that is divisible by 81, in which Cracking the Cryptic will be broadcasting, I predict. Because I'm not sure that we're going to get to 2106. But it would be marvellous if science advances. Anyway, we got a 3-5 pair there. So we've started, sort of. I don't know if we've done anything worth the candle yet. That's not a 5 now. Now, the 20 cage cannot be 3, 8, 9. And it can't be 5. Oh, there are lots of combinations of 20. For some reason, I thought there weren't that many. It can't have a 3 or a 5 in it. If it didn't have a 4 in it, right, we know exactly what it is. It's got a 4 in it and 7 and 9. Now, how do I know that? Because a 20 cage, 1 and 2 are too small to go in it, because the other digits would add up to 19 or 18. 6, if you didn't have a 4 in it, and you're not allowed 3 and 5, the next 3 minimum digits are 6, 7 and 8. They already add to 21. It's too many. So it's got a 4 in it and a 7 and 9. Everything else in this cage is 1, 2, 6 or 8. In this box, not this cage. Everything else in this box is 2, 4, 6, 7, 8. I don't think we can make progress on the 25 cage. I'm not sure. I'll come back to it if we can. Now, in this box, we've either got a 5-5 pair here by Sudoku rules or a 1-1 pair. Now, the 5-5 pair, bear in mind the rule that says that either the blue diagonal adds up to 20 or 25 and the green to the other number. 20 is a very low number for that. 18 is the absolute minimum if you had 1, 2, 3, 1, 2, 3, 1, 2, 3. So 20 only has 2 degrees of freedom away from that. You could only use 1, 2, 3, 4 and 5. And if you used 5 twice, you would have twice used 2 extra degrees of freedom. Okay, so what I'm saying is the blue cannot be the 20 diagonal and have 5s in. It could be the 20 diagonal and have 1s in, which these probably are 1s, or it could be the 25 diagonal and have 5s in. Let's have a think about how that would work. If you had 5, 1, 2 and 5, 1, 2, that would be 16. You'd have to have maximum of 9 here, which looks like 3 and 4, well, and 1 or 2. There would still be 1 degree of freedom there. So it's not impossible for the blue diagonal to add up to 25 and have 2 5s in, which is a shame because I was hoping to rule out 2 5s completely. But let's think about the green one just in case. See here, this could easily be 1, 2, 3, just adding up to 6. I don't see why not. In fact, you would know the exact order, 2, 1, 3. Here, well, these could be 1, 2, 3, but not if that was a 1. And here they could well, no, hang on. Something's going on here. There's a 3 and a 5 X-wing. 5 is in one of those 2 cells. And 3 is in one of those 3, because 3 and 5 are used twice in this box. This cage, I really must learn to use cage and box correctly. Oh, so I don't know. I was hoping these 20 and 25 diagonals would iron themselves out quite quickly, but I don't think they are doing that. There's no way I'm using the snake yet. I'm going to have to do something with these diagonals. Right. I mean, I could consider that this 20 cage doesn't have a 5 in it, but unfortunately it can still be 3, 8, 9 or 4, 7, 9. Yeah, I mean, it's restricted to those. At least the adding cages aren't allowed repeats. Okay. So let's go back to thinking, okay, I didn't get very far in working out whether these could be 2 5s. Let's then instead think about how would this be the 20 diagonal? If this was the 20 diagonal, each box would have a total that could be no more than 8 in it on the green line. And in this box particularly, that would mean the 1 was involved on the green line, and this cell would have to be a 5. That's interesting. So, the 25 diagonal, right. So if the green diagonal is the 20 diagonal, it's got the 1 in these cells, and that's a 5. And this is a 5, and the minimum here is 8. 5, 1, 2, let's say, another 8 is 16. This would have to be a 3, and this would have to be a 4. And this would be 1 or 2 as well. And these, which I was positing as 1 or 2, could go up to 1 and 3 in one case. There's only 1 degree of freedom left. That's quite interesting. So if green is the 20 diagonal. This is a pair of 5s, and there is a lot of freedom reduction on blue. But there is a lot of freedom reduction anyway on blue if it's the 20 diagonal. So if blue is the 20 diagonal, we're already up to 8 minimum there. And that's used all the degrees of freedom. If blue is the 20 diagonal, this is 2, 3, 1, 1, 2, 3, 12, 3, 4, 1, 20. So it's possible, maybe even likely. But what's happened on the green diagonal, which would have to be 25? We've got a 1 here and 2 and 3 used there. These digits are at least 4, 5 now, and that's at least 2. That's at least 11. 1, 2, 3 is 17. 3, 2, 1 here is 23. So there's 2 degrees of freedom that way. That's quite interesting. So there are many fewer degrees of freedom than I actually thought when I was first thinking that 20 has 2 degrees of freedom, but 25 has plenty, because these have to work together in some way. Now, okay, let's think a bit more. This is so constrained that this goes 1, 4, 3 if blue is the 20 diagonal. 1, 4, 3 there. That's a 2, 3 pair. That's a 2, 3 pair. And you've got 1s in both of these places. In fact, you would have to have 1s in all of those 3. 1 has to be on that diagonal, I'm sure. I'm not sure now, actually, because there were degrees of freedom left. Oh, hang on. I was positing 4, 5 in these cells, but if we're assuming those are 2 1s, these are both 5s. Yeah, sorry, let me go back. You couldn't put 5 on this diagonal. Yeah, this one would be, yes, if the 20 is blue, that's 1, 4, 3. And this is 2, 3 there and a 1. And this is a 1 and 2, 3. Now I've just worked out you couldn't put a 5 on this diagonal, and you've used 1, 2 and 3. They would have to be a 4 and a 6 at the minimum. That's 10. With a 2 in the middle, that's 12. 2, 1, 3 there is 18. 1, 2, 3 down here is the absolute minimum. Now there's only 1 degree of freedom. You can't expend it in this box. You could in this, it could be 4 and 7 around a 2, or you could put 3 in the middle. Ah, this is so confusing. Haven't got anywhere near the snake yet, of course. Right, but it's very difficult for this to be the 20 diagonal. I'm going to keep thinking about it in case something else pops out. Well, now I'm interested in where 1 would go on this bit of the line. You'd have a 1 here, and you'd have a 1 in one of these cells, obviously. So that's the only cell where 1 could be. So what would happen to 1s? They would be here, here, here. We know they'd be in those 2 cells. I'm positing that blue is the 20 diagonal here. It would have to be on the green diagonal there. One of those 2. One of those 2. One of those 2. There'd be no 1 in the 25 cage. That's all right. No problem with that. Gosh, I mean, this is possible, and the other way is possible just. Maybe it's the other way I have to rule out. 2 5s here is so constraining. There'd be a 1 here, it couldn't be there. So there'd be a 1 here, and 1's in those places. This is if blue is 25 and has the 2 5s on. Oh, the 1 in the middle box would have to be in the middle cell, because these two would be 1s looking at the other cells. Then there'd be a 1 in that cage. This, no. In the 25 version, I think we're allowed 9 in the top cage, in box 1. Oh, this is confusing me. It would have to be on the diagonal there. This is in the situation where we're reaching 25 with 2 5s on the blue diagonal, and I'm highlighting 1s, and the green diagonal has to only be 20, and every segment of it has to have a 1 in. Wow. I mean, it would be very constraining. 1s would have to be in those positions. Right, I'm going to colour those. Yellow is a terrible choice. Let's try red. And those are possibles. And that's what happens if these are 5s, because the blue is 25. If the blue is 20, the 1s go here and here, and here, because that's absolutely minimized. 1 4 3 1 2 3 1 2 3, and then we definitely need 1 here. Yeah, we need 1 on that diagonal, and there's going to be 1 in one of those two. I just did this a moment ago. It really shouldn't be quite as hard to do it again. I think I did anyway. Yeah, we had to put a 1 on this diagonal, that's right, and then 1 in one of those cells. Right. Either way round, God, no wonder the tester had difficulty with this. Let's call those purple, but in some of these positions, it's uncertain where purple is. However, these two cells in the puzzle both have to have 1s in. Either way round you do it, they're definitely 1s. So I'm putting them in. And now I can finish this cage, 1 4 5. That doesn't do anything for me except take 1 out of that cell and out of those two. Now, one of these is definitely a 1, and one of these two is definitely a 1, and that isn't. And there can still be a 1 in the 25 cage, which might matter at some point, I'm not sure. Now, come on, think of something else, Mark. What else is there? That is now a 3 5 9 triple, so 9's in one of those two. Oh, that places 9 up here. And that's a 7 4 pair. Well, surely none of the versions I've come up with allow this to be a 7, do they? No, in the... Better go through it again, sorry. In the version where blue is 25 and those are 5s accordingly, there's 1 degree of freedom along here, so that can't go up from 4 to 7. In fact, that can't go up from 3 to 5 in that version. Let me just check that. 5 1 2 is 8, 5 1 2 is 16. These have to add up to 9. There is only 1 degree of freedom from 3 4 1, so that would have to be 4 and 3. Right, in the other version, where the green is the 25 line and these are 2 1s, the blue line adds up to 20, and there's 1 degree of freedom away from 1 2 3 1 2 3 1 4 3. No, there's no degrees of freedom. So this is always a 3, and this is always a 4. They must be right. That's a 7. That's a 5. There's no 3 in those cells. It's now a 1-5 pair. There's no 5 in those cells. That's a 3-9 pair. This is not 4 or 7. I've got 2, 6, and 8 still to place. I can't put 2 on this green line now. And I can't remember how important that was. This, by the way, can only be 1 or 2 on this line because it is so constrained. Okay, now 2. Does 2 have to be on the green line? And if so, it's in this cell. Does 2 have to be on the green line? So there are 2 versions that I'm working with simultaneously. In one version, these are 5s. This line adds up to 25. And the green line only adds up to 20 with a minimum 1, 2, 3 here. 1, 2, 3 here. 1, 2, 3 here, but could this be 1, 3, 4? Actually, I think maybe it could. But if this was 1, 2, 3, this would be 5, 1, 4, 10, 18, 22, 25. No, that would be bust. Ah, in the green version, in the version where green adds up to 20, this is definitely 1, 2, 3 up here. Because there's only 2 degrees of freedom maximum. These are 5s, so I'm allowed, and those are 1s, so I'm allowed to put a 1 here. And I've got probably 2 and 3 there, but there are 2 degrees of freedom. However, that is 2 or 3, so that's taking away 1 of the degrees of freedom. This is now 2 and 4 at best. So there's only 1 degree of freedom away from 1, 2, 3 here, which means 1, 2, 4 is possible, but 1, 3, 4 is not. And therefore 2 is on this line, even in the version where green adds up to 20. And in the version where green adds up to 25, let me just check that because I'm not sure I have. This is the 20 version with 1 there. Maybe 2, yeah, we've got 8 minimum. Oh no, these are 5s in the, yes, these are 5s in the 20 version. Hang on. I've lost track of where I am. It was the 20 version on green that I worked out 2 had to be on the line. So the 20 version on blue, these are 1s. The 20 version on blue, those are 1s. There's 2 or 3 or 2 or 4 there, 2 or 3 or 2 or 4 there, 1 or 2 there. These are 1, 2, and 3 or 4 here. The minimum for these is 2, 3, 5 in our quest to keep it down to 25. So they add up to 10 minimum. We've got 6 there is 16. Got a 9 maximum here if I'm right. Oh, well, how did that happen? Now I'm very confused because I didn't think there was that much scope. Sorry. I'm finding this very difficult. I almost need to run 2 versions of the puzzle side by side, but I'm not going to do that. Right, let's think again about the version in which this is double 5. No, this is double 1, so it's the green version being... The green version being 20 needs a 2 on the line here. I've worked that out. The blue version being 20, that needs these to be 1s. With 2, 3 or 2, 4 there, 2, 3 or 2, 4 here. This is a 1. This is 2 or 3 or 4. But the minimum here is not 2, 3, 4, because one of those digits goes there. The minimum is actually 2, 4, 5. No, it's 2, 3, 5. It is 2, 3, 5. That's 10. Up here, 1, 2, 3 is the minimum, which is 16. And then you could have 9 here, which could be... it can't be 1, 3, 5 because of those. Oh, but 1, 3, 4 is possible, and use the degree of freedom somewhere else, which would have to be in this box. That would go 3, 1, 4, 2, 1, 3, 14. Then you'd have 11 here. This is to avoid 2 being on this line. You'd have 11 here, which with a 1 there, I'm saying could be 2, 4, 5. But 5 would have to, 5 would have to be in the center, which would break the line. Yes, 5 can't go on the line. 2, 3, 6. 2 there, 4 here, 3 and 6 there. This is almost certainly what it is. Oh no, but that's just to keep 2 off this line. I don't know why I was hoping to find that it failed. Yeah. That's not, I haven't quite got there. But we're getting close. It's a very, very interesting conundrum, this. Because it's so tightly wound, this snake. Oh, goodness. Right, 1 has to be on this diagonal, because it's either there, or else that's a 5, and then this has to be a 1. So 1 is in one of those 2 positions, definitely. Now, 1 can never be there in a 25 case, because the other digits couldn't get there. So I don't know, is that... This is where 1 is going to be in the version in which this is 2 5s, isn't it? Yeah, I can't rule that out yet. Oh, this is so weird. This is such a strange and troubling puzzle. I wonder if I can always say the corner is a 3. Or can I always say this is a 2, 3 pair? Have I got any scope on that? If this was 2, 1, 6, then we're not on the 20 diagonal. We'd be on the 25 diagonal. This would be the 20 diagonal with 2 1s there. So 2, 1, 6. This turns out to be at least 2, 3, 6. That is actually the minimum, because we can't put 5 in those positions. Oh, we could put it there. That's strange. 2, 4, 5, maybe. So 11, 17. Maximum here is 8. And the minimum is 6. That's 2 degrees of freedom. Well, you can never boost the 2 or the 3 up to being a 6 up here. I've got to put 2 and 3 up there. I'm putting 2 there, and I'm putting 3 in the corner. And that's a Christmas tree. Oh, Christmas tree, oh, Christmas tree. How lovely are your branches. Right, these add up to 22. They've got a 9 in. And they're either 5 there and 9, 8 here, or they're 9, 7, 6 in some order. And I don't know what that order would be, annoyingly. But I've got a 2 here. Is that any use? No, it really isn't, is it? Is it worth thinking about these now? Let's say that was a 1. The minimum that these are is 2, 4, 6, 8. That's already 20. If that's a 2, these could be 1, 4, 6, 8, which is 19. This has a maximum value of 6. Which is a bit of a surprise, but, you know, we'll find out anything we can. There's a 3 in one of those cells. That's not a 9. I don't know why I keep allowing it to be a 9. 7, 4, ah, come on, 2, 6, 8. It's so annoying that I can't tell which way round this thing goes. I think both ways are just as likely as the other. Now, if that wasn't a 3, I think it doesn't have to be. 3 and 5 are in those cells, so it can't be 1, 3, 5. We know that. I'm wondering, should I just be adding the 2 diagonals together now? This is something that hasn't occurred to me to do. Maybe I should. Maybe I should just add them all up together. And I might find that things are eliminated. Ah, that's interesting. So these would be at least 1, 2, 3, 4, 5. Let's assume we had a 1 in the middle. So that's counted twice, and they now add up to absolute minimum 16. 3, 4, 1 here, and we're up to 24. That 2, 1, 3, and we're up to 30. Let's say 1, 3, 2 here, and we're up to 36. Plus 1 there, and we're looking for a 45 total. These have a maximum of 8. So they can only use the digits 2, 4, and 5. That one can't be 5. That was valid maths, I think. I'm just going to recheck it. 1, 2, 3, 4, 5, including a doubled 1 in the middle there, is 16 towards the count of 45. 8 there is 24. 6 there is 30. 6 here is 36. Maximum 9 there. Yeah. Oh, maximum 9. So a 6 is possible as well. Oh, bother! At least I checked. Now, is there some reason this can't be 1, 2, 3, 4, 5? I bet there is. So if that was a 1, this is a 5. On this diagonal, that has to be 2 or 3. Then 4's on this diagonal. I cannot see what the problem is. There probably is a problem somewhere and I can't get it. 5, 3, 2, 4. These include, they're selected from 1, 6, 8, 7, 9. 1, 7. If 9 was in this group, they would be at least 1, 2, 4, 9. Oh, I think I've done my maths wrong. No, I haven't, because they can't be 1, 2, 4, 9. They'd be 1, 4, 6, 9, which is 20, and that would be maximum 5. Yeah, that's okay. 1, 5 pair, 1, 5 pair. That seems very unlikely to be a 5, frankly, but I don't know. There is a 5 in one of those 2 cells. That's just Sudoku. There's a 3 in one of those 3. And there is a 4 in that box. Just trying to find some Sudoku to do. Right, 1 is definitely in one of those 2 cells. So if green is the 25 and this is the 20, 5, 5, 1 there, 2 or 3, 1 there, because reds would be 1s, and that would be 2 or 3. And either 1 or 2 there, and it's not actually known which it is. And then you'd have 1 here, but 5 here, and 2 or 3 here. So, at least 2 and 6 in these cells. No. 1, 5, 2 or 3. So these could be from 2, 3 and 4. Why can't I see what's wrong with that? Something is probably wrong with it. This is tough. Oh, Adrian, you've given us something to work with here. Goodness gracious. Am I meant to use the snake? I have been avoiding it, but here's something I've thought about the snake, actually. It's 12... To have both modular and entropic properties, this snake is going to be a set of repeats after repeats after repeats. Because if you imagine any 2 digits, I'm just picking a random 2 digits from the keypad here, of 2 and 6. That's used 1 from the top row and 1 from the middle row, 1 from the second set down, 1 from the third set down. The next digit along such a snake would have to be a 7. And then after 6 and 7, the next digit along would have to be a 2. And then a 6, and then a 7. And I think that must apply all the way along the snake. I'm pretty sure the snake is 12 digits long, and it's 4 digits repeating 3 times each in a regular fashion. Ah, so all the caged cells in the puzzle, the snake doesn't go through. I tell you what, it also doesn't go through row 1, column 1. Oh, don't know about that. Right, it doesn't go through any of these cells, and yet it achieves, it can move in any way it likes. It can't cross itself, but it can move horizontally, vertically, and diagonally. And it's going to have 4 lots of each digit that it uses. Well, some of these are getting used up a bit. So 5s, I've already got 5 5s in cages. If 5 was one of the digits on the snake, it would have to pick up the remaining 4 5s in its 12-cell path, which would have to include that one, and one in this case, one of those 2 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, okay, it could just achieve that. No, it couldn't, actually, because those 5s would have to be in positions, say, 1 and 10. They would only be 9 cells apart. So you could only do that if you could join those by a course of snakes. Oh, by the way, you couldn't do it because although you could visit a snake in box 5, there isn't one to pick up in box 4. I'm just imagining the minimum path here. There we go. 1, 2, 3, 4, 5, 6. Oh, well, you get there a lot quicker than I thought. But 5, 6, 7, 8, 9, 10. But then you would be coming out. It doesn't quite work. It doesn't quite work because 2 5s would have to be in column 4 for that. Oh no, look, the first one could be there. That snake would work. Oh, bother. So I can't even rule out 5s from my snake. That's so irritating. Okay, maybe it's not time. Maybe I was right. It isn't time to think about the snake yet. But I need to figure out how these blooming lines work. Okay, if the blue was a 20 and that was a 2, these would both be 1-2 pairs. They'd be the 1s, they'd be the 2s. So you'd have 2 in all of those positions. You'd have a 2 somewhere here. 2 definitely there. We've got 2 there. 2 in one of those 2. 2 in one of those 2, and 2 in one of those 2, and probably on the line. It looks like it could work for there to be a 2 in the corner, even on the blue line being 20. Oh, goodness me, I'm so stuck. That is 6, 7, or 8. Oh, are these 1, 2, 3, 5? No, they can't be. They are, no, they include 2, 3, and 5. That could be a 2, 3, 5 group. In fact, that's quite likely. It'd be great to rule 2 out of this cage. Then it would, and as well as 1 somehow. Then it would have to be 3, 4, 5, 6, 7, which is impossible. So there is a 1 or a 2 in it. That's interesting. So either there's a 1 there and that is a 2, or much more likely there's a 2 in this cage. In fact, 2, 4, 6, 8. Let's say there's no 1 in the cage. What did we make it? 2, 4, 6, 9. Oh, maybe there's no way of actually making up the right numbers. 2, 4, 8, 9. Let's say this was a 1. I'm selecting from 2, 4, 6, 8, 9. Together they add up to 29. I can drop 1 out into here, which is 6, 8, or 9. And this needs to be 4 less than that, which needs to be, 2, 4, or 5. Well, that could be 2 if that was 6. This would be, no. I'm imagining this as a 1. Yeah, that's no good. If I'm selecting from 2, 4, 6, 8, 9 here, I cannot make up this cage. That's it. This is craziness. Imagine this is a 1. I'm selecting from 2, 4, 6, 8, 9 here. I'm going to go through this again. That adds up to 29. So I drop 1 digit out, which ends up here. The difference between that 29 and this 25 is that that is 4 bigger than this. But this then is 4 bigger than that digit, which is therefore 6, 7, or 10. Well, it's not 7 and it's not 10. That would be a 6, but this would be a 2. And where's the other 2 in row 1 if I'm positing that that's a 1? It's in the cage again. There's 2 2s in the cage. That's not allowed. This is not a 1 in the corner. This is a 2. Now, did I leave? Yeah, this is the only place 1 can go now, in box 1, and it's not on a line. And that's the one, I think. Now, I don't know for sure. It's got a 6, 8 pair in column 3 now. That's so weird. Right, but this has gone up to 9. So if this line is the 20 line, with 5s on it, these are 1, 2s. If this line is the 25 with 5s on it, these are, no, hang on. If this is, right, if this is the 25 line with 5s on it, these are both 1, 2 pairs. If instead this is the 20 line, and we've already had 9, that's impossible. We're up to at least 21. There we go. I mean, it was just that. Good grief. Okay, these are 5s. The blue line is the 25 line. The other digits on it are 1 and 2. The 1 down here is in the corner. That's a 2. This is a 1, 2 pair. Now we look at the 20 line, which is green and which has a lot fewer degrees of freedom. It's only got 2 degrees of freedom from 1, 2, 3 in each box. It's got to use one of them here, where this is at least 1, 3, 4 now. So it's only got 1 degree of freedom here. We're either on 1, 2, 3 or 1, 2, 4. So that's the 2. And this is 3 or 4. And I don't know what my pencil marking was meant to mean. That is 3 or 4. Here we're looking at either 1, 3, 4 or 2, 3, 4. And that's it. We can't be looking at 1, 2, 6 or 1, 3, 5. So that's a 3, 4 pair, definitely, on the line. Wow, here we go, here we go. This puzzle's remarkable, actually, remarkable. Okay, let's go back up here. We now know 1 is in that. 1 is in this cage. That is 6, 8 or 9. Now, again, these are 1, 4, 6, 8, 9. I'm not afraid to try this all over again. They add up to 28. So the difference between that and that is 3. Well, that's only achievable by 9 there and 6 there, surely. No, 6 there and 3 there does it as well. 9 there and 6 there won't work, in fact, because that would put 6 in the cage again. So it's 6 there and 3 there. And now this group is a known group of cells which are 1, 4, 9. And this must add up. 8, 1, 4, 9, 3. It does. That's 25. There we go. Oh, that was the key to the whole thing. My goodness, this puzzle's crazy. Right, 9, 4, 6, 3, 1, 7, 8. That's a 2, 5 pair. 2 is an X-wing between those 2 bits, and I can place it in column 6. 1s must be finished, aren't they? No, they're not. That's not a 1, though. Okay, 3. That 3 sorted out the 4, 3 in the middle section. Now that's a 9 for definite. Just going to get rid of that colour, which didn't really matter. And those can lose their colour. And basically, well, you see, I don't even know if my original colouring was right. I'm taking out the colours there because I'm not sure about these 1s anymore. Anyway, 1, 4, 9, 2, 5, 3. That's a 6, 7, 8 triple. That's a 9. Now, those add up to 12. The other 2 in the cage add up to 13. This is now 5 or 6. I bet there's a lot of Sudoku to do now, so I'm going to try and find it all. That's not 3 or 4. 6, 7, 8. 6, 7, 8, 9. Now, one of those is 3 or 4. Oh, these aren't 2s. That was what I was trying to prove earlier. I wonder if I just got my maths wrong and it was provable that there wasn't a 2. These are from 4, 7, 9 and definitely include a 9. Right, what do I know about the relationship between these two? It adds up to 4. Well, that is done. I'm just checking. 1, 2, 3, 4 is 10. 2 and 3 is 16. We're coming to 20 on this. on this diagonal. That's 1. That's another 3 in the corner. That's 3 in the spot. Light. Pretending to be a Christmas tree. That's a 2. That's 1. That's 5. I think maybe my colouring was right originally. I'm just getting rid of it now. Because we found all the ones now. They're all in. Oh, I've still got the snake to find. I forgot Mr. Snakey. I did some thinking about him though already, which is nice. Always nice to think about your snake at Christmas. I mean at New Year. 2, 2. That's a 2. 3, 9, 2, 1. Oh, come on. There must be a bit more Sudoku before I have to do the snake hunting. 2, 3, 5, 1. I mean, I'm so excited now. It's really ridiculous how overexcited I suddenly get. There is a 5 and it's there. So that's an 8 to make the 25 cage work. Okay, good. 4, 6 and 7. I don't know how they dispose. 6, 7, 2, 1, 5. 3, 4, 8, 9 here. Oh, don't tell me I'm going to have to find this blooming snake on my own. I want the puzzle to be nearly done when I look for it. That's what I want. 3, 6, 8, 5, 1, 2, 9. This is 4 or 7. These include a 3 or a 4 and a high, well, either a 9 or a 7 or an 8. That's no use. 6 and 8 are there. 5 is in one of those cells. I feel like I ought to know which one and I don't. Oh, there's a, no, not quite a 6, 7, 8, 9 quad. That would be useful. There is a, that's not a 3. That's not a 4. And yet one of those is 3 or 4. Okay, I'm going to think about the snake. Right, let's see if we can rule anything out. So again, I'm going to colour up the cells in cages because the snake is not allowed to pass through a cage. So we'll go green. No snake in green. No snake in the grass. The snake can't get into that cell. It is, oh, there's another cage. Right. It is 12 cells long. And it repeats 4 digits again and again. And it must go into those, well, into at least 4 boxes to do that. Right, what digits are in cages too often? Look, there are 6 5s in the cages now, so it doesn't travel through a 5. It would help if I could find the other 2 5s, but there's one there and one there. What about 3s? 1, 2, 3, 4 so far. Not enough. Now, it must either hit 2 or 8 because it's got the modularity requirement of either hitting 2 or 8 4 times. And also, there's 4 or 6. Oh, we've got 4s in 3 cages at least. That's not enough to rule it out. 9s? Ooh, yeah, hang on. There's a 9 in this one, a 9 in this one, 9 there and 9 there, and 9 there. There's only 4 9s left in the puzzle after those. Could the snake get them all? Actually, I think it could, because they could all be quite close together. Sort of round here. Ah, blast. But 5's not in, so actually there's only a few combinations left. It could be 2, 4, 9, 2, 6, 7 in any order. Ooh, 2, 6, 7 looks appealing. 2, 4, 9, less so. See that 2, 2, 4, 9, like that. It could just reach 1. But then it couldn't carry on 2 and then 4. Oh, I mean, that's quite interesting. Am I really going to have to, I probably am going to have to try and figure out how this can all work. Oh, this is not quite what I wanted to be doing after all the hard stuff. Right, 249 is one, 267 is the other. Well, that could start beautifully up there. 672, 672, 67. Blimey. I mean, I could be onto something here. 672, 672. I'm not saying that that would definitely work, but it's not far off it. Okay, but with an 8, it would be 816 or 834. So 168. That 6 couldn't be involved because it couldn't reach a 1. That one couldn't reach a 1 either. Are there other 6s eliminated? No, not really. Bother. But there's a lot of 1s eliminated. 1, 2, 3, 4, 5. Oh, 1 may be unavailable. Because that 1 would have to be one of them. And you can't get to another 1 within 4 goes. Right, 1 is out. 1 is not on the snake. The snake does not use 5 or 1. So 672 is possible. 249, I'm not sure I ruled out. $249, I think it looked difficult. That's not enough. Yeah, okay, so I almost need to write these down. 267, 249, but then only 834. Is 348 possible? There's a lot of 3s ruled out. This one could go 3, 8, 4, but it can't hit another 3 after that. Hang on, what are the combos I'm saying? 267, 249 or 348. The only way 3 can be involved is with 8 and 4. And this 3 would be ruled out because it couldn't reach another 3. And now how many 3s have I got ruled out? 4 of them. Okay, 3, 4, 8. Oh, I've got another one ruled out here. That's 5 ruled out. It would have to use the other ones. This 3 can't reach a 4 to the north, so it would have to go 4, 8, and then it can't reach another 3. That one is ruled out. It's not 3s. It's not 3, 8, 4. 2 is in the snake. It's either 267 or 249, but I don't know which 2s, but I know that 4 of the 2s are in the snake. And I think 249 is unlikely, especially as 4, 9 are all ruled out up there. And 9 there. There's only, oh, and 9 there. There's only going to be 4 other 9s. One of them is here. Well, that's well set up for a bit of 249 action. But how you can't get through here to the 2. If you use one of these as a 9, it's going to take 2 steps to get to that 2. Nine, 2, 4, 9, 2, can't reach another 4. I don't think these 9s can be in play. They can't go that way. And using only 9, 4, 2, you can't get through there. Right, 249 is out. It is 267 is the snake. Okay, it's quite exciting. 672 is available there. 627 would work there. 267. This is difficult. Now, we can't join through here. Same reason. 2s can't connect. Oh, they could now. 2, 6, 7, 2. I see. Oh, maybe I have not eliminated 9, 2, 4 strongly enough. Because if that's a 9, one of these is a 9. And then we could go 9, 4, 2, 9. No, we can't go through a 4 there. Okay, it's still impossible. But it was closer than I realised. I hadn't realised it. But we are looking at a 2, 6, 7 snake. And I want it to start up there, but I don't know. 2, 6, 7 snake. Which digits are very unavailable? None of those. That's the problem. I mean, we've lost a 2 and a 7 up there. And that's about it. Ah, bother. But we're going to have this problem that we can't cross over rows and columns that we've crossed. Like if I did use 6, 7, 2, I could never use column 7 again. So I could come out of that with a 6, a 7 in one of those and a 2, and then a 6 and a 7. Yeah, that's interesting. I mean, this does work, but the principle is quite interesting. You couldn't use 2, 6, 7 there without then having to be off to one side or the other afterwards. Is it not enough, Adrian, that I know the snake is using 2, 6, 7? No, it's not. I know, I'm only joking. Ah, okay, cells that cannot be used include all those, because they can't be 6, 7 or 2. Oh, that's weird. Okay, that doesn't. What can't be 6, 7 or 2? Oh, every blooming other marked cell virtually has got 6, 7 or 2 as a candidate. Right, but we have limited the snake possibilities. Right, we can't come here and then go down this way because we will run out of possible 2s and we can't cross this line again. Oh, this is madness. So could we come from here and then go through here? 2, 7, 6, 2, 7, 6, 2, maybe. No, in fact you couldn't, because from that 2, oh, that might be enough of them. 2, 7, 6. No, you can't get to that 2 and then get to that 2 without using a 7 or without using both a 7 and 6 in this box, and that breaks the connection to this one. So you'd have to start here. And if you started with this 2 and you needed a 4th 2, now I'm not saying you couldn't start, well, I am saying you'd have to start there. You need a 4th 2 somewhere here or here. But to get there, you'd have to use a 7 here. And that won't work, because you must have used a 7 here, because that would have to be the 6 before the 2, because you can't use the green. That's mad. But that doesn't work either. So we can't use these 2s. I think they're off limits. I think they're off limits, and I'm closing all that section down. And now I think we have to go through here, because we have to use 4 2s, and there are 3 in the northeast section and 3 in the southwest. 6, 7, 2. There's no point going for a 2 here. This one's off limits, I think, because how are you going to come through those rows to get from that 2 to that 2 with a 6 and a 7 in these columns? Surely you'll have used those before. 2, maybe not. 2, 6, 7. Yeah, you will. You'll have used a 6 there to get to a 7 there. That's what's going to happen. We are going to have to pass through there, in fact. I've worked that out. So I can write in a 6 and a 7. That might help with the Sudoku. This is mad. This is definitely on the path. So my purple snake path, no, it doesn't go there, it goes through there. And I'm not even going to connect, well no, it's got to be a 2 after that. I am going to connect it up to the 2 and it's got to be a 2 after this, but I'm not going to connect that up because I don't know. Let's try and do Sudoku now. That's not a 6. These don't have a 7 in. That is a 7. Those are a 4-9 pair, and they can go green, as can that 1. I didn't realise that. That's got cut off. I wonder if we're going to have to go through this gap as well. Don't know yet. In fact, no, we're not. No, we are not, because we go 2, 6, 7 in that order. To go through here, we'd go from a 2 to another clashing 6. This stuff's all out of bounds. This is madness. Right. This is brilliantly fun, though. 2, 6, 3. That is now a Sudoku 5. That's a 2. 5 is out of bounds. Have we got all the 2s in the grid? Oh. Yes, they're all done. We don't quite know which 4 are in the mix. 2, 6, 7, 2. You could touch... you could get quite a few. You could go 7, 2, 6, 7, 2, 6 here. Goodness. Anyway, that's not a 6 by Sudoku now. Has this helped any of the rest of the puzzle? That's not a 7. One of those is a 7. One of those 2. This is 4 or 6. Oh, I still haven't done this 20 cage. That's a bit strange. Had a 3 or a 4 in it, didn't it? Oh, I'm going to have to do the snake. I'm going to have to do the snake. What a puzzle. Well over an hour now. 2, 6, 7. So the maximum number of cells, we can't go through that. 4 or 8. So those are off limits. So there's a maximum 6 cells there, plus 2 there. We need 4 more, and we need to reach another 2. Gosh, 7, 2, 6. 7, 2, 6. That's so plausible for the finish. 7, 6, 2 looking this way. Then we need to go 7, 6, 2 again. Is my original 6, 7, 2 out of bounds now? No, it's not. You could go 6, 7, 2, 6, 7, 2, 6, 7, 2, 6, 7, 2. You'd still have another possible 6 left over, as far as I can see. I mean, I might be missing something about how the digits are going to work when we start filling in the Sudoku a bit more. But I'm really struggling with the Sudoku. Right, 3's in one of those cells. That's not interesting. 5, 6, 1, 2. This is 3, 7, 8 or 9. Don't know where 4 goes in this row. 2, 7. That's not 7. These add up to 11 being... Oh, they don't have a 7 in either. There's no 7 in this cage. And therefore, it is a 9, 8, 3 cage. And the 3 is there. Right, that might inform the Sudoku. That's 3 now. They're not. One of those is 3. Right, well that puts this out of bounds, because it's either a 3 and out of bounds, or it would have to go through there. So I'm just ruling that out. Probably didn't need to do it. Now, that's an 8, 9 pair. And they see both of these cells, which also can't be 3, 1, 2, 4. That is 6 or 7. That's 5, 6 or 7. 4 is in one of these 2. That was predictable. Wow, how can this still be so difficult? It just is. Just is. One of those is a 7. Now that can't be on the path, surely. 6, 2. How would you get to it from a 2 going this way? That's not on the path. If you went to this cell, you would finish the path there. That would be a head or tail of the snake, because you would have, oh no, 7, 6, 2, 7. Well, not absolutely necessarily. Oh, 4 is in one of those 2 cells in the row, so those can't be 4s. Now I've placed 4 in column 7. There is some complicated Sudoku still to do. That's a 4. That is not in the path. Okay, the path is narrowing. That has become a 7, and that's not on the path either. That's an 8-9 pair, and that's not 8. And these 2 aren't 7. 6, 7, 2. Gosh. The boa constrictor is getting constricted down. So 1, 2, 3, 4, 5, 6, 7. We need 5 more cells off the end here. And we're going 2, 7, 6, 2. We've got to go round this corner now. If you went through that, you'd get stuck because you'd go 7, 6, 2, and then you couldn't move again. So we've got to go through here. It's got to be 7, 6, 2, and we're going through there on the line. I mean, this is brilliantly weird. That's now an 8. That's a 9, that's an 8, that's a 9, that's an 8. That's 9. Come on, Sudoku, bring me home. 4, 9 there. Now, this must be a 6. Yes, that is known. That's a 9. 7, 4, 8 and 6. A little deadly pattern that's going to be snake resolved. You knew that. Right, these ones are 3 and 7, and we do know the order. And that's 3 and 9 ordered. Oh, not there, not there. In the next cells, 3 and 9. And now I've just got the deadly pattern. This is 4, 6, 8. So that's a 6, 8, 4, 5 and 7 down here. Right. Now, how's my snake doing? We've definitely filled in 6 cells. We've got a maximum... Oh, I've got a maximum 4 more there. Yeah, we're going to have to go up to here, just as I saw at the beginning. And then to go 2, 6, 7, 2, we're going to have to go like this. And there we are. And this has to be a 6 on the snake. And we have completed the year of the snake. What an extraordinary puzzle. That's just amazingly hard. Adrian, you are a crazy man. But happy birthday to your dad this coming year. I was trying to green that as well. There's our snake left behind. Oh no, I wasn't trying to green that one. 6, 7, 2, 6, 7, 2, 6, 7, 2, 6, 7, 2. Modular and entropic all the way through. And what a tough puzzle that was. Very pleased to get through it. I found it very difficult. Mind-blowing. Thank you for watching. Do point out any errors in the solution path. It's not impossible, as you know. And I will see you again tomorrow. Bye for now. Happy New Year.